Okay, so this is the last part of our tutorial for the Beady Rings model. And in the previous video, we were able to do the first update. So we created a function that does the first update, and now our grid started with all cells empty, and now we have our first private space and our first public space. I'll just double check. Let's print it. So let's see, we are printing first public position 2, 3. So this should be 0, 1, 2, 0, 1, 2, 3. And 3, 3, the last cell here, is the private position. Yeah, that's correct. And now what we're going to do is that we're going to update the variables. Let's think about it. How do we do that? We have a function that does that. Update data, we pass our variables to store the positions, and we're going to update it. So let's go to update data. This is actually pretty simple. There is an issue of order that we need to follow. So we need to update our empty set. We need to update maybe private list and set. We need to update public list, and we need to update our frontier. So why are we using all these updates? Well, this implementation works. I'm working with lists and sets, and you can implement in different ways. You could use a 2D list to represent the grid spatially, but I opted to use a more abstract representation. So our grid is represented as an empty set. We are going to store our private positions in a list and also in a set. The reasons that when we transfer the data to Grasshopper, it's interesting to have in a list because we are going to see the order where each of the positions was created. However, when we use a set, we can do some operations more efficiently. So that's why I'm using both, but you can choose one and then transform to the other one whenever you need. And for the public positions, we are only using lists. And for our frontier, we are using a set. So let's remember what are these elements. So in this case, empty set originally had all the cells. Now we are going to eliminate this cell and this cell from the empty set. Okay. And we are going to add this cell to our private list and set. We are going to add this cell to our public list. And we have the frontier. So the frontier is basically composed by potentially by the 4 neighbors of the public space, but one of these neighbors already is always occupied by this private space. So we reduce to 3 neighbors, and now we also have other restrictions, like neighbor will be outside of the grid, like this one, so we will not accept this one. So we will not accept this, we will not accept this, but this will be part of our, I'll draw an F here, frontier, frontier, okay? So this is the frontier. And why do we store the frontier? Well, it's a way to sample more efficiently, because think like for the next step, I could sample from our grid for an empty set and say, well, I need to sample and check if it's a neighbor, my new public space is a neighbor of this one. However, if I keep a frontier updated, I can sample my next update, my next public space directly from this frontier. So that's what we are going to do in the next step. But for now, let's just update the variables. Let's think. Empty set, what can we say here? We can say, well, empty set's a set, so we can use subtraction. I could say equals empty set minus a set containing public position, private position. So I'm converting to a set because I'm doing set operations. This one's a set, so I need to subtract this from this set. Or I can simplify this and use a subtraction update. Actually, it should be minus equal. So we can say minus equal, and solved. We updated our empty set. Now let's update our private list and set. So we can say, let's start with the set. Private set. We can use union. We can use the update with union. So we are doing union with another set, or maybe I can just add to my set. Just you can choose the operator or the function, the method you're going to use. I'll use here the union. Okay, I'm going to use the union, but potentially you can use add. And I'm going to add private position. And we are going to do private list dot append. In this case, we can just append directly private position. Now we're going to copy these and we're going to do the same for a public list. So let's say public append public. So finally, this is the part that we need to think a little bit. It's a little bit more complex. First of all, I need to do this after I update the empty set, because in the future you notice that maybe one of my potential positions for a neighbor, for a frontier, is already occupied. So the way I'm going to check if this is a legal cell for my frontier to add to my frontier is that it needs to be in the empty set. So let's update with a test. We already have the function to do this, so we can say public frontier. We can use this, and we can say get for neighbors of type. I'm not sure if you remember this function. You should. Of type. We should public position. So we are trying to get the 4 neighbors of our new public position that are in the empty set. That's why the empty set should be updated at this point here. Otherwise, if the empty set's not updated, we might get a wrong cell here. Okay, let's test if it's running. Usually it breaks when I do this. Yes, this is a list, this is a set. I need to convert to a set. And let's see what happens. Now it's running. Let's print everything here. We are printing public position, private position. Let's print, what else do we need? Let's print our private list. Let's print public list, and let's print our frontier. Let's see. So 2333. Okay, 33 is in the private list and 23 is in the public list. Perfect. And our frontier is 22. This is 22, and this is 13. It's working. First step's working. I'll just show we can use, if you don't like to use this form here, let's change it. I'm going to say private set.add. Let's see if this is going to work. Maybe it looks better this way. And public frontier, we can also add. Then we don't need to use this set operator. So, but the point is that we're going to get a list here. Oh, here's where we shouldn't add, because this is a list. So we don't want to have a list inside a set, and actually Python does not accept. So maybe let's see if Python has, if we look for the documentation in the sets, let's see if Python has an operation to add multiple elements. So what we can do is, what we can do here is that let's check add. Okay, we have add. Yeah, it doesn't have an operation that add multiple elements except for uh, intersection update, difference update, discard pop. Yeah, so let's just use the union. Let's use the union for that case. So let's keep this case with the union because we have potentially multiple elements here. And I think for this one we can use add if we prefer. Yeah, so it still works, so it's up to you which one you're going to use. Okay, so now for the next updates, now I'm not going to do the next updates, but I want you to think a little bit about this. When we press through here, we're going to do the next update. Only think about the next update. We're going to do that multiple times with our timer, but now think about the next update here and try to implement it. So what you can do is say like, well, maybe my next update, it's potentially I can use this cell here as my public space or this cell here as my public space, but remember that you might have to do some tests. So let's do some steps here on the diagram and see what happens. So maybe this is my new public space I sampled from Frontier, and my private space, notice that I can when I add it here, now I need to check if this position is legal. In this case it's legal because if I potentially I can have my private space here, 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 here I cannot. So these are the three possible positions. This is legal because it shares an edge. This is legal. This is legal. So let's say I opted to have it here. Now this is my second one. So this is going to be my next update. Now I'm going to do another update here. And let's decide that this next one is going to happen here, and my private space, potentially private space could be here, here, or here. So I'm going to say that I chose it to be here, right? That's the new private space, and this was my, it's legal because it's not sharing a vertex. So this is true. Now we notice that for my next update, things can get a little bit complicated in the sense that I might let's say that I choose my, oh yeah, I always don't forget to expand the frontier. Now this is my I didn't do for the previous one, but let's think about this step. The frontier should be here, 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 and here. So this is my new frontier, and let's say I decided to have my next update. I'll change a little bit the color like this. I decided to be here. That's my new public space. Okay, and this is my new public space, and the possible positions for my private space now are here and here because this is occupied and this is occupied. But let's think a little bit. Can I add my private space here? You'll say, well, actually not, because if I add it here, I'll be sharing a vertex, so that's illegal for my private space. Can I add it here? Yes, luckily I can add my private space here. But let's imagine that for some reason I cannot add it here. Then you couldn't add your public space here. You need to go back and choose another element of the frontier and test the public space and the private space. But for now, I'll just add this here. That's good. And this is my third. And as I mentioned, remember to update the frontier. So as I add this element from the frontier is occupied, and now this becomes a new element from my frontier. Yeah, this frontier, frontier, frontier. If I had more cells here, this would also be in the frontier. And that's it. Take some time to think about this logic and implement the next step.